Well, hello everyone, this is Mr. Freiberg, and this is the third lesson of your four for week 1 of term 2 for online learning. And as you can see, this lesson is entitled Volume of Rectangular Prisms. Now, this PowerPoint that I'm running through here is also accessible straight underneath where you found this video, so you can actually work through or get a copy of this PowerPoint presentation without any of the annotations, and you can keep that for yourself. And also underneath that is a copy of some class notes. So those class notes are based on this PowerPoint presentation, and the idea being that if you would like to take any notes, some of those notes are already pre-printed for you and you essentially just fill in the blanks. I would highly recommend that, as there are some diagrams coming up. If you are using your maths book, then I would suggest the first thing you do is to obviously put this as your heading, Volume of Rectangular Prisms, and you might also like to put today's date, which is Wednesday the 22nd of April. That's when this lesson should be completed. As this is a video, at any stage you can pause it if you need to write down some notes. For instance, you could, if you haven't written the title down yet and I click forward to the next slide, you could pause it, go back, and you can write the title. Similarly, there's the learning intent, which we would again like you to write down, and the learning intent for today's lesson is that you'll calculate the volume of rectangular prisms and cubes. And again, if you need to, pause the video and you can write that down. And you can see there the success criteria for today is to give you a definition of volume, to recall the use of the formula length times width times height, particularly for a rectangular based prism, and also start to investigate an alternative formula which you may have seen last term, which is the area of the base multiplied by the height of that prism. Now, my understanding is that the volume of a prism was touched on, volume of a rectangular prism was touched on very briefly by both Ms. Moriarty and Mr. Eden in term 1. And so this is a little bit of a review and perhaps a little bit of finishing off of that before we really get into term 2's work, which is, as I said, this week all about algebra. Okay, so there's a little bit of a revision before we touch on volume. Area. Now, the area you looked at in term 1, which is the area inside a two-dimensional shape, and area of rectangles, parallelograms, and triangles, which I think you learnt in term 1, and the areas of those figures are always stated in square units. So you saw measurements like millimeters squared, centimeters squared, and meters squared, as you can see there. Now, these notes here, if you would like to take a copy of those, please pause the video and write them down. I'm revising area because there are some applications and extension of area when it comes to working out volume. Okay, so here's the volume of rectangular prisms. First thing to note is that there is a definition of volume, and that's it right there. Now, I always recommend to my students that you write that definition down, and so I'd like you to write now. Again, you can pause the video at any time. So volume is the amount of space that is inside a three-dimensional object. I'll also get you to write down that there is another measurement here, which is called capacity. Now, capacity is a little bit different from volume. So as I said, volume is the space that's inside that object. Capacity is the amount of liquid that it can hold. Now, in grade 7, you're not going to look at capacity that much. A little bit later on you will in school. So I'll just mention capacity there, and that's probably all I'm going to say. What I will say, though, is that the measurements of volume are now in cubed units, or I call them sometimes cubic units, and they are millimeters cubed. So you'll notice the little 3 is written up above there. Centimeters cubed, and lastly meters cubed. Now, here's a lovely rectangular based prism down here in the bottom right corner. This shape here, it's a rectangular based prism. Now, to calculate the volume of that rectangular based prism, what you saw last term was a formula that looked like this. It looked like length multiplied by width, multiplied by height. All right, and if you look at that rectangular base prism over here on the right hand side, there are three measurements. There's the length, there's its width, and over here there's its height. So if I'm going to calculate the volume of this rectangular based prism, I'm going to get its length, which is 10. I'm going to multiply that by its width, which is 5, and I'm going to multiply that by its height, which is 4. 10 times 5 is 50. 50 times 4 is 200. Now, if this was centimetres, then the answer would become 200 centimetres cubed. Now, you might like to pause the video right now and write down those notes that you can see on the screen, perhaps even including the example. You might even like to try and draw the rectangular base prism. As I said though, if you've grabbed a copy of the pre-printed class notes, you should be able to find a similar example to this, and you might like to write those notes down. Okay, let's move on. Here's a we do. So this is one that you might be able to try yourself. So the question is, calculate the volume of this rectangular base prism, which is down here on the right hand side, this one here. Now again, to give you a little clue, it has a length, it has a width, and it has a height. And what I'd like you to do is to find its volume. Write down the formula and show all the working out. So what I would expect you to write down in your book is the word volume, and I'd expect you to write down the formula. The formula, which is length times width times height. Now, I'd like you to pause the video right now because I'd like you to fill in what you think the length is, what you think the width is, and what you think the height is, and then to actually calculate what the volume of this rectangular base prism is. So pause the video now. Okay, let's check. So the length we said was 6, the width is 4, and the height is 5. 6 times 4 is 24. 24 times 5 is 120. Now you'll notice that this rectangular base prism actually has units. They're all centimetres. So the answer will be 120 cubic centimetres. If you tried that yourself and got it right, please give yourself a tick. If you've written that in your book or you've written it on the handout, well done. You've calculated the volume of a rectangular base prism. Now, one for you to try yourself. This one, I'm not going to write anything on this screen, and what I'd like you to do right now is to pause the video, and either in your book or on the handout, if you've taken a printout of that, I'd like you to calculate the volume of this rectangular base prism using the formula that we've just done. So pause the video now. Okay, let's check. So again, the formula that you need to write down is volume equals length times width times height. But if I come over here to the right hand side where this rectangular base prism is, which one's the length, which one's the height, and which one's the width? Well, I'm actually going to put that as the length, and I'm going to put that one as the width. And you can see the 10 over here is how tall it is. That's pretty consistent for all rectangular base prisms. The length is how long the base part is, so along here. The width is generally how deep it is. And then of course the height, which is pretty self-explanatory, is how tall it is. So if I now put those numbers in my formula, the length is 4, the width is 5, and the height is 10. So on my calculator I'm going to go 4 times 5, which is 20. 20 times 10 is 200. And you can see over here, the units this time are meters, and so you probably guessed it, the units will be cubic meters. Again, give yourself a tick if you tried that one yourself and you got 200 cubic meters, because that's very well done. You've now calculated the volume of a rectangular prism all by yourself. Great job. If you didn't quite get 200, please pause the video now, correct your work and make sure that you have the correct thing in your book. Okay, time for you to practice a few. Now, obviously, some of you have access to a textbook and some of you don't. If you do have access to a textbook, the questions that I'd like you to do are on pages 369 and 371, and it's Unit 6.6, all about volume. And I'd just like you to try questions 2, 3, and 4. So it's all parts of question 2, and then question 3 and question 4. Either way, you'll notice here that I do have a little note for you. It says that, could you please complete the work? And once you have, could you please scan or take a photo of it so that I can see what you've done? Now you can either save that into the assignment Dropbox that's in our online classroom, our eLearn classroom on the Learning Place, or you can email it to me. Okay, now my email address, if you haven't already seen it, it is on our eLearn classroom, but mine is dfrei3, and obviously then at eq.edu.au. Right, and you can email me a copy that way. If you have the video and you have the PowerPoint presentation and you have the handout, I have actually provided you a copy of the questions. So there's question 2, question 3 and question 4. So there's question 2 and question 3 and 4. So what I'd like you to do is all of question 2, all of these questions here, okay, all of them, and then have a go at question 3 and 4. Guys, I reckon that should take you about maybe 10 or 15 minutes, and I'd like you to pause the video for that long or until you get those completed. There is a second part to this lesson, and I'd like you to start that when you've finished those questions, and I'll see you there. Okay, so hopefully you have now completed those textbook questions 2, 3, and 4 that were on the previous slide. There is a little bit of an additional section now. You'll notice it still says volume of rectangular base prisms. Now if you read through these notes with me, it says that you may recall that a rectangular base prism can be made up of several layers of cubes. You may have got to play with cubes and put them together in layers last term. Each layer has the same rectangular shape, meaning there is the same amount of cubes in each layer. Take a look at this diagram down here. So you'll notice that there is 3 layers of cubes, and each one of those layers is 4 units long and 2 units wide. And so each of those layers are the same. You can also find the volume of a rectangular prism by counting the number of cubes on the bottom or top face. We usually use the bottom because that's the base. And you'll notice that in bold I've called that the area of the base. And then multiplied this by how many layers of cubes there are. In other words, that's the height of the prism. Now, boys and girls, this gives us another formula that we can use to work out the volume of a rectangular base prism. And this is it right here. The volume of a rectangular base prism can also be calculated by working out the area of its base and multiplying it by its height. Now, I don't want you to think that this is earth-shatteringly new, because it's not. If you look at this rectangular base prism over here, you'll notice that the area of its base is just its length multiplied by its width, and there's its height. So we're actually just doing the same thing, except we're cutting out that extra step of putting in length times width times height. Okay, we don't need to put that anymore, because the area of the base is 4 multiplied by 2, and it's 3 lots of blocks high, so we're going to go 4 times 2 times 3. 4 times 2 equals 8. 8 times 3 equals 24, and so the volume of that rectangular prism is 24. Now if they were centicubes, each one of those cubes is worth a centimetre, so it'll be 24 cubic centimetres. So it's just a slightly different way to calculate the volume of a rectangular base prism. Now there's a lot of information on that slide, and I'd like you to pause the video, and I'd like you to copy down all of the information that's on that slide into your book, and I'd like you to do it underneath the heading volume of rectangular prisms. So underneath that heading right there. I'll see you when you finish writing those out. Okay, let's continue, and let's now do one of these questions together. So here over on the right hand side, here's my rectangular base prism. You notice it's all made up of cubes. And the first thing we need to do is actually count up how many cubes are in the bottom piece. So down here along the bottom, and then how tall it is over here. So along the bottom, I've got 1, 2, 3, 4, 5 pieces along there. And I've got 1, 2 along the width. So that's kind of like my length and my width. Now, how tall is it? I've got 1, 2, 3, 4 layers. So I guess you could say my height is equal to 4. Now I should be able to work out the volume of my rectangular base prism. Now I'm not going to use length times width times height. I'm going to use this new formula that was on the previous slide. So I'm going to say the volume is area of base times height. The area of the base is 5 long, 2 wide, and the height is 4. So I'm going to go 5 times 2 times 4. 5 times 2 is 10. 10 times 4 is 40. And again, if these are centicubes, let's make it 40 centimeters cubed. Again, you might like to pause the video and you might like to copy those notes down. If you have the class notes, you might like to fill in the question on the notes. Okay, it's your turn. Now this question might look familiar to you, but what I would like you to do for this question is I'd like you to use the volume or calculate the volume using our new formula, which is area of base times height. I'd like you to pause the video and I'd like you to spend a couple of minutes to see if you can work this question out yourself. Okay. Volume equals area of base times height. That's our new formula. It's a rectangular base prism. So we've got a rectangle on the base, and how do we find the area of a rectangle? We multiply its length by its width. So we're going to go 4 times 5, and then we multiply by its height. And there's the height right there, 10, just as before. 5 times 4 is 20. 20 times 10 is 200. This time we've actually got the units there, which is meters, and so it's going to be 200 meters cubed. Give yourself a tick if you got that right. If you didn't quite get it right, please fix it up. Again, you might like to pause the video so that you can do that. Okay, so now you've seen 2 different ways to calculate the volume of a rectangular base prism. And what I would like you to do now with these textbook exercises, so this is the remaining exercises in Unit 6.6. You'll see there it says Unit 6.6, all about volume. What I would like you to do with these exercises is I'd like you to use the new formula, which was area of base times height. Okay, area of base times height. I'd like you to use that formula to calculate the volume of those questions there. So question 1, all of them, question 7, 8, and 9. And again, when you've finished, please make sure that you take a copy of what you've done and get it to me either on the learning place or via email, which was back at the previous slide. Again, if you have your textbook, you can open your textbook up and you can work on it. If you don't have your textbook with you, if you flick through the next few slides and pause on each one, you will notice the questions that I have set you. So there's question 1, question 7, question 8, and question 9. If you would like a paper copy of the questions, I also have those on the online classroom, on the eLearn classroom, and you'll notice that there is a link there to a document which has just the textbook questions. And you can print that out as well if you wish, and you can use that to work your answers out if you don't like to look at the computer screen. So what have we done in this lesson? We've defined volume. We've hopefully used the formula length times width times height. And now we've also investigated this new formula, which is area of base times height, to help us work out the volume of a rectangular base prism. That's all for this lesson, boys and girls, and I look forward to seeing you tomorrow, where we're actually going to take what we've done today and apply it to hopefully solve some problems. I look forward to receiving all of your completed work with some volumes of some rectangular based prisms. Thanks everyone. See ya.